All right, guys. So let's do lesson 7 here. It's called Euler's number. It has something to do with exponential functions. We'll see that as we get there. All right. So we're going to talk about what Euler's number is, why we care about that, how to simplify expressions with that number in there, and we'll talk about functions that have that number in it, exponential functions. If I can activate this from here today. So Euler's number, what is it? We use the letter E to represent it, and it's about 2.718. It's a lot like pi, 3.14. It's an irrational number, meaning you can't make it into a fraction. It has no pattern. It never stops. Where does it come from? Lots of places. There's a few ways you can get that number. But right now, what we saw in the video is that, you know how like when you have compound interest, the more times you compound it, the more you make. But it increases at a slower and slower rate because you're breaking your percentage up more and more. So it does keep increasing, but it slowly levels off. And the level that it levels off to is 2.718. It's Euler's number, so it's kind of an interesting value there. So if you take your compound interest formula and you let the number of times you compound it go to infinity, you get E out of it. Kind of cool. Why do we care? In the video, you guys saw that it's useful in statistics, biology, and physics. Also, in calculus, it's really the best way to represent exponential functions. And we're studying exponential functions right now, so that's why it's making its appearance here. So, all right. So we're just going to practice doing some basic math here with Euler's number. Now we've got an introduction to it. So let's go ahead and do these. So if I want to do e to the third times e to the sixth, all you do is you add those exponents together, and you get e to the ninth. Heard it down. Number 2. Like in a lot of stuff you're going to see here, it's like, that's not new math. I knew that, Mr. Bailey. But I'm just showing you this is e. And what's important to understand is that's not a variable. Like usually we do these things with x, which are variables. This is actually a number. E is just a number, but we use the letter e to represent it. But yeah, a lot of this should be pretty much review for you, but we're doing it with e. So here we can reduce that. 16 over 4 is 4 over 1. Right? You divide the top and the bottom by 4. Do you guys remember what we do here? You subtract them, right? So what's 5 take away 4? It's 1, right? Now, that means I have e to the first power. But it only goes in the top or the bottom. Where does it go? It goes in the top. And why is that? Because that's where the bigger one was. So like if you were to reduce, everything off the bottom would cancel out, but you'd be left with 1 on top. Okay? Now, so that's it. So you reduce your coefficients like normal, like you'd normally reduce a fraction. Subtract your exponents and put the result either on the top or bottom, depending on where the bigger one was to begin with. Now, as you guys know, we don't really need the 1 on the bottom, right? And we also don't need the 1 here. So on a multiple choice test or something, it would probably just be written like that. All right, let's take a look at number 3. Subtract the exponents. You reduce them, yeah, like you normally reduce a fraction. All right, so here I've got this big expression here, and I'm squaring it. So what you're going to do is you're going to apply this square to each piece. Okay, so we have 3 is going to be squared, and then e to the negative 4x is also going to be squared. And do those separately because the way that it plays out is a little bit different. So 3 squared is 9. And then this one here, you square it, what you do is you multiply the exponents. So what would that come out to be? Negative 8. And the x just stayed there. Negative 8x. All right. The last thing we'll do is we'll I just want you guys to know how to do this on a calculator. So it says, use your calculator to change your answer from number 1 into a decimal. Now there's 2 ways you could do this. One way is less accurate, but it might have some meaning to you. For instance, e to the 9th power, that is approximately 2.71 to the 9th power, because that's what e is. It's about 2.71. So you could, on your calculator, just type in 2.71 to the 9th power. You'll get a pretty close answer. But there's actually an E button on here, and I just want you guys to see where it is. So come grab a calculator. Since I'm not from the table, grab a calculator for you guys. I'll show you guys how to type it in there real quick. So for number 4, I'm going to show my work here because I have space down here. What you guys are going to do on your calculator is you're going to push the button that says second. It's in the top left-hand corner. So push the button that says second. And then you're going to find the button that looks like this. And it has a little e to the x above it. It's down here on the left-hand side. It says ln and then e to the x. So second and then ln of x. At that point on your screen, you guys should see e with a power waiting for you to put the power in there. All right? So all you have to do is type 9 and then push enter. And what do we get? Let's see. Y'all should be getting, for number 4, the answer is 8103. And if we just round it out to about, I don't know, 3 decimal places, you get that. Are we in agreement? Okay. So the reason I did that is because I just want you guys to see how to use a calculator for 1. And for 2, it's hard because it looks like a variable, but it's not. That's actually a number being raised to the 9th power. So e to the 9th power is actually 8,103 something, right? So that is Euler's number, just working with some basic simplification. Here's some exercises for you guys. I'm going to let you guys work on those for a bit, and we'll see what you guys get. There are the answers. We'll move on here. So you guys may recall this little expression here, and we learned that this thing here, bonus point time, what's the b called? Raise your hand, I'll give you if you know. That's the a, but I'm still going to give you a point. What's the b called? Yeah? It's called a growth factor. Good, thank you. I hope both of you get some points. Thank you. Now, the growth factor, when it's bigger than 1, you have exponential growth, and it looks like this. You might want to add that picture to your notes there. And when the growth factor is less than 1, we have exponential decay, which looks like this. Okay? So that's old. We learned that a little while ago. We're gonna keep that, but we're gonna modify it a little bit. Now, exponential functions are written like this. All right. Now, I want to show you guys something interesting here. If I were to take this e, and I'm going to put the k inside the parentheses with the e, I can do that. You guys don't need to write this. I just want you guys to watch for a second. I'm going to pick a number for k. I'm just going to make it equal 2. Now, someone with a calculator, would you guys punch that in your calculator? I'm going to ask you what you got and just say, what's e to the 2nd power? Go ahead and type that in and see what you get. Okay, thank you, sir. All right, so that's my b value. So on these problems here, your b value is e with that k value next to it. So e to the 2nd would be 7.3. That's my b value. So is that bigger than 1 or less than 1? That is bigger than 1. So this is growth. Now I want to show you guys something else now. Suppose I gave you this instead. E to the negative 2. let's punch that into our calculator and see what we get. What's e to the negative 2? 0.135. Notice that my b value now is less than 1, which means that we have decay. Okay, so what kind of conclusion can we come to from this? Whenever it's written this way instead of this way, what kind of conclusion we come to? Well, did you guys notice that the k is positive? I get a b bigger than 1. If the k is negative, I get a b less than 1. So we have a different way of looking at it. So instead of thinking of it as when b is greater than 1, it's growth, and when b is less than 1, it's decay, here's how we can think about it in this form. We could say when k is positive, it's going to be growth. When k is negative, it's going to be decay. Okay? By the way, another way to think about this is just as the number. Oops. What did we say e is equal to? 2.71. If you square that, is that going to be bigger than 1 or less than 1? Bigger. Now this one, e to the negative 2, you guys remember what negative exponents do? They make it a fraction, so this is really e over that. So you have 1 over some number that's bigger than 1, which is, when you have 1 divided by a number bigger than it, you get an outcome which is less than 1. So, I don't know if that helped or not, but here's the thing I want you guys to walk away from. Here we go. If you have this is going to be growth. If you have this, that is 1 over e to the x. Okay, so the negative exponent causes it to flip, and that is decay. Okay? So make sure you guys have that on your notes there. I'll wait a second if you didn't write that, because I told you not to write it a while ago. This I want you to have. Okay, so here's our questions. Determine if the following exponential functions are growth or decay. So here we go. On this one, my k value is 2. That's a positive value. So since k is positive, we would say this is growth. In other words, the function would be increasing, would be getting bigger over time. Adriana, I think I already called on you, right? Or did you? Did I call on you yet? Okay, so Adriana, what's my k value on number 2? Yeah. On this one, we would say since k is negative, this is decay. In other words, over time, the function is decreasing. It's getting smaller over time. So the k is the number in front of the x. If it's positive, we have growth. If it's negative, it's decay. Now, this one's kind of a tricky one. Let's see here. Oh, Adrian's not here. No Keyman. No Miles. A lot of people absent. All right. So, Aaliyah, you got kind of a tricky one here. So, what is the k value on this one? You want to try? Someone think they want to take a crack at it? What do you think? It's 1. It's a little tricky. The k is the number in front of x. There isn't a number. But usually if there's no number in front of x, it's 1. So, in this case, since k is positive, this is growth. So in other words, number 1, the graph would be going up, And on number 3, the graph will be going up. But on number 2, the graph goes in a downward direction over time. Okay. So there's 2 problems there for you guys. You don't have to write out the whole sentence. I would have, if I were you, I would have written these out on the notes. But for the student practice, you can just put growth or decay. You don't have to write your explanation.